Welcome, Farmington High School, to Unit 7 Notes 4 Probability Review. We are going to talk cards, dice, and quarters, as we are all gamblers in the dark. So, let's talk about it. Probability. So we're going to review this stuff. A measure estimation of how likely it is something that will happen. Probabilities are given a value between 0% will not happen and 1 or 100% chance it will happen. The higher the degree of probability, the more likely the event is to happen. The notion probability of A, or P with A in parentheses, the probability of A. Number of successes, or what we want, divided by the number of possible outcomes, what we want. Alright, so you guys got to figure out what we're talking about as we move through these. So the probability with dice. So if you take a dice, look at that, a 4 becomes a 2. So rolling a 2 or 3. So rolling a 1. Notice if I click on this thing, there's like 6 figures. Look at that, a 1. Number of successes. There's only one. The die 1, the number 1 only shows up one time on a die. Number of possible outcomes. There's 6-sided dice. So the probability is 1/6. Or, since we always need decimals, since we're doing probability, because it has to be between 0 and 1. So I would have said this is a 1/6/7 probability. Okay. There's a 2 or a 3, so you add the 1 and a 1. The number of successes is going to be 2. You have 2 possible outcomes. That is the success of what you want. Out of 6, so 2/6, or I would have said 0.3 repeating. Rolling an even number. So when I look at even numbers, I have a 2, a 4, or possibly a 6. So there's 3 possible successes out of 6. 3 out of 6, or 0.5. Now, rolling a number more than 2. So when I look at that, I know 3 is more than 2, 4, 5, and probably a 6. So there's 4 possible successes out of 6, 4, 6, or 0.6 repeating for a probability. And then I'm rolling a prime number. Looking at prime numbers, I know that 2, 3, and 5 are prime numbers. So I just said number of successes is 3 out of 6, 1/2, or 0.5. So you got to be comfortable knowing dice. You also have to know decks of cards, which everybody just got really excited about. All right, when you look at this, cards per suit, right, there's going to be 13 cards in a suit. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you have Jack is 11, 12 is a queen, 13 is a king. So there's 13 cards in a suit. You also have to know that there's 4 cards of each type, meaning in this red box, there is 4 cards of each type. There's an ace in each suit. Then if you multiply those together, you get 52 cards in a deck. Some other things we need to know about decks of cards. Over here, in purple, in attempted purple, there is face cards. So if I went over this in face cards, that's the jack, queen, and king of each suit. So there's 3 per suit, so 4 times 3, there's 12 face cards. There's also, I think that's supposed to be a tannish color. I don't know. We'll use this purple again, but it's dotted. So this is your number cards, all right? Number cards, there's 9 per suit. So you get rid of the ace, then it's 10 through 2 are the number cards, and there's going to be 9 of them per, 9 of them. Then the last thing you should know is there's 26 black cards, so the clubs and spades are all black, 2 suits worth, and then 26 red cards, 2 suits worth. All right, so then let's do some probabilities with cards. So spades. Probability of spade. If you can look at that, you see that there is 13 successes of a possible 52. So that's going to be 13 out of 52 is going to reduce to 1/4, or 0.25% probability. An ace. is going to be 4. So out of 52, notice they're all out of the number of total things that we have, or 1 over 13, or 0.077. A red card, remember there was hearts or diamonds here, so that's 2 suits of 13, or 26 out of 52. That reduces to a half, or 0.5. Jack of clubs. Good news. There's only one jack of clubs out of 52, so the probability of that card coming up is 0.019. And then a face card, there's 12 out of 52. Because we talked about that. There's 3 face cards and 4 suits, so that's 12 out of 52. That is going to reduce to 2 out of 13. 3 out of 13, sorry, I divided by 4. Or 0.231. So this is just 1 over 52 if you're worried about that. Alright, so you got to be comfortable with decks of cards. They're on your finals, so you might want to play some card games at home. Moving forward, complement probabilities. Alright, these are just probabilities that equal this is an LIES, that equal 1. So that's the probability of A plus the probability of not A would equal 1. So the best example is if we have the probability of heads plus the probability of not heads, which is tails. No matter what, those probabilities are going to add up to equal 1. Right, so you are looking for complement probabilities. Sometimes when there's only 2 options, it's really easy, heads or tails. Sometimes when they say A or not A, that's going to be a complement probability as well. So more probability examples. You have a bag with 3 marbles. So I see 3 red marbles, 2 green marbles, 5 blue marbles. What is the probability of randomly grabbing a blue marble? Well, first off, the ones we want is 5. So there's 5 blue ones. Out of, that's the number of successes, 5. Now the total possibilities is 3 plus 2 is 5 plus another 5 is 10. So I would said what we want is up here with 5. The number of options is 10. So this reduces to 1/2, and the probability of this is 0.5. Alright, so you're going to be doing a lot of total outcomes by the number of successes. You decide you want to read You decide you want to read Harry Potter. You go to your bookshelf and randomly pick one of them. What is the probability you do not choose the first book in the series? So this first book in the series. Alright, first off, there's how many Harry Potter books in the series? I'm thinking the crowd said 7 here. So I know that there's 7, but there's a part 1 and part 2 of number 7. Those are the movies. That don't count, I suppose. So I know there's 7 books now, and there is the first book in the series, so that's 1. But I want the probability that I do not choose the first book. So instead of doing 1 out of 7, you're trying to not choose it. So that probability, that's a complement probability of 6. So the probability of the first one is 1. The probability of not the first is going to equal 6. So 6 out of 7, when you divide that in your calculator, you should get 857. Alright, so make sure when you do these probabilities, you know how many there are actually in a series. Now, moving forward, that's really small. Can I make it bigger? No, this way. I give up. Now I gotta make it smaller. Why doesn't it let me make it bigger? I'm having way too much fun on this. A bowl contains 2 green. So 2 green, 10 blue, 8 red. If 2 stones are chosen at random from the bowl, what is the probability that it is not green? So what I would have done, Oops, this is a 2 green. This is a G. So 2 green. We want not green. So out of this total, I see that there's a total of 20. So not green would have been, look at this. You have to choose blue or red, which is a total of 18. So not green, I would have said 18 out of 20 are chosen at random. The probability of that is going to be 9 out of 10, which is equals to 0.9. So no matter what is chosen at random from the bowl, it's going to be 0.9. Sweet. You need to make a doctor's appointment next week. What is the probability that is on a weekday? So how many days are in a week? 7. There's how many days in the week? 5. Seems pretty simple to me. 0.714. So that's hard to read. I'll write it again. 0.714. 5 out of 7. Then we have number 5. There are 4 males and 6 female puppies at a breeder. What's the probability you would get a female puppy? The first things I always do is I calculate that there's 10. Total is equal to 10 puppies. So then I'd have 6 females out of a total of 10. That is going to be 0.6 probability that you'll get a female. Let's look at this. A single card just shows that random from a deck of 52 playing cards. What is the probability of choosing a card that is not a diamond? Good news, there's 13 diamonds. So if I did 52 minus 13, I'd find out that there's 39 non-diamonds. So that's what I want. Out of 52, 39 divided by 52 is 0.75 that are non-diamonds. Alright. The only thing I might have messed up is that marble one, or the stone one. But you can call me out on it. We can talk about it. We can discuss it a little bit. You want to make sure that you know the total number before you can calculate any probabilities. As always, thanks for listening. Have a nice day.